Okay, so here we are with the equation for a parabola written in factored form. We have two factors that we're given. We have the factor of x minus 1, and we have the factor of x plus 3. And what we learned was that these factors help us find the x-intercepts. So if we take x minus 1 and set it equal to 0, and x plus 3 and set it equal to 0, we can use our addition and subtraction properties of equality to solve for x. So here I would be adding 1 to both sides. Here I would have to subtract 3 from both sides. And so my final answers for the x-intercepts are x equals 1 and x equals negative 3. Written as ordered pairs, that would be 1, 0, and negative 3, 0. Now, in terms of the vertex, what we learned was the vertex is always halfway between the two x-intercepts. So let's look at a number line. So if this is negative 3, negative 2, negative 1, this is 0, and then 1, 2. And so we have x-intercepts, we said, at negative 3 and positive 1. So we need to find what's halfway between negative 3 and positive 1. The total distance is 1, 2, 3, 4. So halfway is going to be 2 from either here or here. So 2 from 1, I'm going to go back 2, and I'm going to land right here at negative 1. So I now know that the x-coordinate of my vertex is negative 1. And in order to find the y value for my vertex, everywhere there was an x in my equation, I am now going to replace it with a negative 1. So negative 1 minus 1, this becomes negative 1 plus 3. Now I have to do some computation. So negative 1 times negative 1, I'm going to get negative 2. Negative 1 plus 3, I'm going to get positive 2. And when I multiply negative 2 times positive 2, I get a negative 4. So I now know the y value of my vertex. It's negative 4, so I'm going to bring that right up here and finish my ordered pair. So positive 1, negative 4, coordinates of my vertex. So let's label these. This is my vertex. Those are my cats you might have just heard. These are my x-intercepts. The other thing we can find is the y-intercept. And we learned that in order to find the y-intercept, the shortcut was to multiply these two constants together, right? This is what's going to produce the c value in standard form. So if I multiply negative 1 times positive 3, I get a y-intercept of negative 3. And just for kicks, if you want to see the whole multiplication done, x times x is x squared. X times 3 is 3x. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. And then we do our combining of like terms, right? Since we have these two like terms in the middle. And so the x squared is going to stay x squared. A 3 minus 1 is going to give me a positive 2x in the middle. And then I still have my minus 3 at the end as my c value. Oh, this is acting up again. So you can see that the minus 3 here that we did from the distributive property into standard form, it's the same number I got here, but I got this one with a lot less work. Okay, so use those to help you answer question number 4.